Hello class, welcome to Unit 3.8A Standard Form. Okay, so when we look at standard form, it is going to be in the notation of AX plus BY equals C, where basically your A, B, and C are all just variables of a number. And at this point, those A, B, and C's aren't really going to tell you too much about our graph. Now, of course, the X and Y values, they're going to continue to represent the infinite points on your graph or on the line. So when we work with this, again, we will be able to do a few different things with it, but really A, B, and C are numbers, and X and Y is just going to represent all of those ordered pairs on your line. So one of the biggest perks of your standard form is when you're trying to find your X and Y intercepts. Because in standard form, we know that the X-intercept is always going to be over here where your Y equals 0, and your Y-intercept is always going to be here where your X equals 0. And what that's going to help us with is, especially when we look at some word problems down the road, and when we look at these equations and finding those values. So if you look at this first one, 4x plus 3y equals 12. Let me zoom in a little bit on this one. And based on what we just talked about, the x-intercept is always when your y equals 0. So all we need to do is plug that in for y, and that way we can solve for x. So anything times 0 is always 0. So what that's going to leave us with is a 4x equals 12. So really the only thing we need to do is divide by 4 using these inverse operations, and now we know our x-intercept is 3. So a lot of times with x equals 3, we also want to rewrite that as a point on our graph. So that takes the point 3, 0. And when you do your y-intercept, what we talked about was y-intercept is always when your x equals 0. So all you're doing is plugging in x for 0 plus our 3y equals 12. And again, 4 times 0 is just 0. So what that leaves us with is 3y equals 12. And we divide by 3 using our inverse operations. And we know y equals 4. Now again, we do want to kind of practice writing that as a point because that is the point 0, 4 on our graph. So there we go. We found our x and y intercepts for 4x plus 3y equals 12. And we'll talk about some more things to do with them later as far as how to graph. But for right now, finding x and y intercept is really just plugging in your zeros in the appropriate places. So we just got to remember, as we look at example B, if we are trying to find the x-intercept, again, this is when your y equals 0. So if we plug in, now we got a negative 3x, so we got to be careful there. And when we do this 5 times 0, we know that that is just 0. So really what we're interested in is, what is negative 3x equals 15? Be careful when we divide by the negative 3, which would make our x equal to negative 5. And that's going to leave us with the point negative 5, 0, because we know our y-intercept, or our y in an x-intercept is always 0. In the y-intercept, we know x is equal to 0. So plug it in. And again, anything times 0 is 0. So all we really need to do is say, what 5y equals 15, we need to divide by 5. So if y equals 3, so that's going to leave us with our x is 0, our y is 3, and that is going to be our x and y intercepts. So at this point, take a minute to pause and practice these problems. When you're done with your problems, check your work. Check your work, make sure everything looks good, so pause here and jot down any questions you may have. Example 2, we're going to talk about graphing from standard form. Because the standard form in the ax plus by equals c doesn't really tell us much as far as graphing, what we are going to need to do is find those x and y intercepts. And once we find those x and y intercepts, we can graph them. And then it's really just connect those points. So this is the one time we'll have 2 points to work. So above we solved A, and we found out that the x and y intercepts were 3, 0, and 0, 4. Now remember, the one that has the x in it is your x-intercept. The one that gives you the y, that would be your y-intercept. So when we go to graph these, it's going to be important to know the difference between your x and y. So if we just go into the x-intercept, which was 3, 0, graph that point, and 0, 4, graph that point, what we should be able to do now is just connect those 2 dots, and we have a graph. If we look at this second one, again, we just got to be aware of which one is which. So negative 5, 0, that's our x-intercept. So we'll go over to negative 5, 0. 0, 3 is our y-intercept. So up here to 0, 3. And we will graph those points. Now again, make sure you're using your ruler, get those things nice and straight. All right, at this point, take time to graph those other ones. Now, one thing I failed to mention here is just graph them. Label them by your point. That way we don't have a bunch of little graphs. So that second one was B. First one is A. And as you get through, we'll end up having like all 6 of those lines, C, D, E, F, on the same graph. All right, so pause here before we move on and check your work. Okay, take a minute here. It looks a little jumbled up here, but just kind of look through. We got our A, we got our B line, we got our C line. D is this one down here going up through, E over here, and F would be that last one going through. All right, let's keep moving. Example 2, we're going to take a look at converting standard form into slope-intercept form. So remember, slope-intercept is going to be that y equals mx plus b. So again, we're going to look at these and solve for y. Going back to solving for literal equations, when we are looking for y, we need to start by subtracting 4x. Now, subtracting 4x, we cannot do anything with that 10. So when we solve this equation, we got to keep those 2 things separated. Now, it's usually a good habit of writing your x first, because that's what we ultimately want. And then we have our plus 10. Now, when we go to solve this last step, we are dividing by 5. And remember, we are dividing everything by 5. So when we simplify, this really means we are dividing not only... Oh, let me just move down here a little bit further. When we divide the negative 4, again, we don't really want to simplify unless we can reduce, but we don't want decimals. And then when we look at this one, this is going to really be like 10 divided by 5. So that one can be simplified to a plus 2. And now we are back to our slope-intercept form, which also would be an alternative of, again, finding our slope and finding our y-intercept. And again, we're going to want to be able to make sure we do these. So when we look at B, again, solving for y, we are going to subtract 6x from both sides. Again, making sure that we do not try to subtract 8 and minus 6x, since they are not like terms. And always put that x first, and that is negative. But then we need to divide by a negative 3. So remember, when we simplify this side, that just becomes y. Now over here, what's really happening again is we are dividing negative 6 divided by negative 3, but we are also taking that plus 8 divided by negative 3. So always simplify where possible. So negative 6 divided by negative 3 is a positive 2. and 8 divided by -3. Well, that's going to give us some decimal answer. So we'll just leave that right now for -8/3. And again, we know that when we look at our slope of 2 and our y-intercept of -8/3, we may want to convert that back to a decimal for graphing purposes. But for solving, just leave it an improper fraction. And of course, this brings us to graphing from the slope-intercept form again. Now, this should be a review from our point-slope form. And really, when we look at A, we can look at that as B, that is our y-intercept. Our slope, m equals -4/5. So that just is going to tell us down 4 over 5. So down 4 over 5, and of course we can do that again. If we go down 4 more, over 5 more. And of course we can go up 4 and back 5 to kind of spread this graph out. So right there is problem A being graphed. Let's take a look at B and kind of review that. Again, we're looking for a slope of 2. If we are looking at -8/3, that might be a little bit easier if we look at -2 and 2/3. So that's going to start us down here, about -2 and 2/3, about 2/3 down the way. And what we are going to also look at is what is our slope. So if we're going to go up 2, 1, 2, and then over 1, remember, we are at this point not getting as accurate of a numbers because they don't line up right on the crosshairs. But we do want to make sure when we go up 2 and over 1, we pretty much stay at that 2/3 mark each time we go up and over. Or the same thing, if we end up going down 2 and back 1, we need to make sure we're kind of staying at that 2/3 mark. And once we get them done, that should allow us to get A and B. And as you go to practice solving and converting for those next couple examples, make sure we graph them and label them as well. All right, you can pause here to practice, and we'll move on to check our work. Before you go graphing, make sure you check your work here and make sure we're dividing both the 2 and the 9. And then when we get to this point, we're doing the 5 and the 30 before we kind of put them into our graph. So we should end up with something like this where we have our, once again, we have our A value. We had our B going through there. This long one here is your C, and this one starting up here is your D line. Okay, and lastly, example 3, we're going to practice writing word problems in standard form. Now, in standard form, we have that AX plus BY equals C as a general setup, but we're not always necessarily going to use X and Y. It's all going to be what we define our missing things as. So if we look at T-shirts at a flea market, that costs $4.50 each, and shorts that cost $6 each, and you have $40, write an equation that models this situation. So before we do anything, we don't know what T-shirts. We know they cost $4.50. So if we look at maybe calling that something like a T, T is going to be our T-shirts. And specifically, this is the number of T-shirts. And the other thing we don't know is the shorts. We know they cost $6, but we don't know, again, what the number of shorts we're trying to buy. But putting that together, what we can look at here is we do know that the cost of a T-shirt is $4.50. So that's going to tell us $4.50 times T plus the $6 for shorts. So that would be 6 times S. That is going to equal our 40. So again, it kind of just matches up that our A value would be $4.50, which would end up being our cost. B value, that would end up being the $6. That would be your cost of shorts. Put that all together, and we have a nice little equation to set up. And we'll talk more about some things we can do with that. But for right now, we're just practice setting them up. So we have example B, a small van that holds 8 people. So we don't know how many small vans we have. And a large van that holds 12 people. You have a total of 100 people. Write an equation that models this situation. So again, we're kind of working with S. We'll just maybe call that the number of small vans we might need. And we can call maybe an L as your R. And I would hesitate to use a lowercase l, so that's why you see me writing an L. So this would be your number of large vans. And then we got to write a, model this situation. So if we know we have 8 people per small van, that could be 8S. We know 12 people per large van, so that's 12 times L. And we know we're trying to get 100 people. So again, we're just kind of setting that up right now. And then we'll kind of take a look at some things of how we use these situations later down the road. All right, pause here before you move on to C and D to check your work. Okay, that kind of wraps up there. Again, making sure you use your variables. And like I said, they're not always going to be X and Y's when we go to standard form. A lot of times it's going to be, whatever those things represent. If you use different variables, not a big deal, but we should end up having 79 with your A songs, 99 with your B songs, and a total of 30. And then we'd have the 125 with your drinks and the 20 cents with your salads, and equaling to $6. All right, so that's it for 3.8A.